Hi all, good morning. Okay, we will be seeing today about fuel system. Before that, I'll introduce myself. I'm Sanal Hubert Matthews. I'm the principal consultant and director of Canotech Engineering Consultants. We are basically designers for marine and offshore field, catering to piping, electrical, and instrumentation process control divisions. So, in today's webinar, we will see about fuel and lube oil systems, which is seen in the offshore oil rig. Okay, so when we hear about fuel system, it's like in an offshore oil rig, we have all the equipments like pumps, then various ventilation fans, or a lot of electrical equipments are there, air conditioning. So all these equipments require power. So basically, for power, we need electrical generators. So this generators, for generating electricity, these generators have engines, which is powered by engines. So this requires supply of fuel. So we will see in the presentation like generators, emergency generator, fuel tanks, transfer pumps, then purifiers, coolers, and how the fuel is taken on board. Similarly, what all process is involved in the fuel system, like bunkering, fuel transfer, purifier operation, fuel supply and return. So all this process, we will go through the concept design. The webinar is for understanding the concept of the fuel system. Okay, first of all, we will see the fuel tanks, like what all tanks are there in the offshore oil rig, because fuel tanks store the fuel for usage. So these four tanks which we are seeing is actually the storage tanks. So generally rigs have three or four fuel tanks, which will be storage tanks. So the storage tanks are designed to store fuel for normally 15 days operation. So it varies, like certain rigs may go up to 20 days operation. So there is a quantity of fuel which will be stored on board. Similarly, we have fuel oil dead tank. So fuel oil dead tank is for the is also called as service tank. So this dead tank is designed to have a fuel storage for minimum 8 hours of drilling operation. So there will be one dead tank. Similarly, there will be emergency generator fuel oil dead tank that is separately designated for emergency generator. So it will have fuel storage for minimum 18 hours of operation. That, like, emergency generator supplies emergency power to critical source of equipment. So this consumption, based on this consumption, emergency generator fuel dead tank is designed for 18 hours of operation. We'll see the fuel system. First, we will see about bunkering, how the fuel is, what is the process, like how it is taken. Okay, so earlier we discussed about the storage tanks. So in bunkering, fuel is always taken to storage tanks. There will be two bunkering stations, one on port side and one in starboard side. So in this bunkering process, all the supply header is connected to storage tanks. So once the bunker barge arrives near the vessel, it is connected using hose to the bunkering station, which feeds the storage tank. So this is how an offshore oil rig receives fuel. Like in sea, when during operation, bunker barge approaches the rig and connects the hose to the bunkering station, either on port side or on starboard side, whichever side is suitable for the vessel to arrive. And the fuel is stored inside the storage tank. So this will be the basic concept of bunkering. Now we will see the fuel system transfer process, because for the operation we have to transfer fuel from the storage tanks to various locations. So we will see how the transfer process is initiated. From the storage tank, fuel is supplied to fuel transfer pump. That means fuel transfer pumps take suction from storage tanks. So these pumps, there will be two transfer pumps. This is for redundancy. In case of one pump failure, we need to have an alternate pump in operation. So these two fuel transfer pumps, either one will be running and one will be idle. So this pumps take suction from the storage tanks and is supplies to fuel oil dead tank and emergency generator fuel oil dead tank. Sufficient isolation valves will be there. Also, an option to pump to bunkering stations. In case we want to empty the storage tanks in an offshore oil rig, we can use the transfer pumps to pump back the fuel oil stored in the tanks to bunkering stations, which will be connected to a supply vessel. Also, there will be a connection to mud pits and cement unit. So the purpose of this connection is to assist in drilling. Like fuel oil is used inside mud pits to mix with mud to change the property of mud as per drilling condition. Also, cement unit requires fuel oil for operation. So there will be a tapping from this to cement unit also. This is a concept of fuel transfer, and designers can add required bypass, can provide additional pump. So all this happens in the system design. Okay, now we will see about fuel system generator supply. Like this is the main application. Like generators need fuel for running. So from the dead tank, that is fuel dead tank, we provide supply to generators. It will be this fuel dead tank will be at a this generators will have suction pumps for taking fuel. So this is a concept of the supply system. And as stated earlier, this fuel dead tank will have storage for minimum 8 hours of operation. A critical thing is the fuel oil dead tank. The suction line for generators will have a quick closing valve, which will have an on-off operating handle outside the machinery space. So in case if we activate a quick closing valve in case of a fire or a dangerous situation, if we activate in an emergency situation, we can activate the closing valve from outside the machinery space, which shuts off the fuel to prevent a further explosion or further fire damage. We can use this closing valve application. It is also a class requirement. Okay, earlier we saw fuel supply. Similarly, there is a fuel return. Like the fuel supplied to generators will have a fuel return. So this return fuel is passed through a coolers, fuel oil coolers. These are air-cooled units, air-cooled fuel oil coolers, which returns to fuel oil dead tank. So there will be a supply from the fuel oil dead tank to generators, and there will be a return from the generators. All the fuel which is supplied will not be used by the generator. So the return fuel will pass through fuel oil coolers, which will pass to fuel oil dead tank. Okay, now we will see the purifier operation. Like in fuel oil system, we know the fuel supplied may not be that pure. The quality of fuel can vary. So we will have onboard fuel oil purifiers, which will purify the fuel. We will see how the system operates. So from the storage tanks, purifiers take suction. So there will be two fuel oil purifiers because one will be running, one will be the redundancy one for alternate operation. So this purifiers take suction and purified fuel oil is passed to fuel oil dead tanks and emergency generator fuel oil dead tanks. Similarly, this purified fuel can pass back to the storage tanks. This is for batch purification. Like we can take from any storage tank, purify, and either we can discharge it to same tank or we can discharge it to the next storage tanks or dead tanks. So this is the concept. We can provide additional isolations, additional bypass lines. So that is the designer's criteria. Sufficient isolation valves will be provided in the system for required operation. Okay, so that was about the fuel system of main engines. Now we will see the fuel system for emergency generator. So emergency generator takes suction from emergency generator air tank, fuel air tank. We earlier mentioned it will have a storage for 18 hours of operation. So this suction is given to the emergency generator and the return flows back to the same air tank. So this is a simple operation. So emergency generator will be used during emergency situation, during power outage or critical situations where the main generators are not operating. Okay, so this is a fuel system. And emergency generator also from the air tank suction side, there will be closing valves which can be activated outside the emergency generator room. So that is the purpose of closing valve. In case of a shutdown required, we do not have to go inside the room for shutting down. We can operate the closing valve from outside the room, which will shut off the fuel supply to generator. Okay, now all these systems which we discussed is combined into a P&ID. So this is the layout view of the P&ID. So we can see a large number of pipes because all these systems are combined into one diagram. There will be storage tanks, air tanks, equipments, purifiers, fuel coolers, transfer pumps. So entire system is compactly put into one diagram, which is the fuel oil P&ID. So this is a fuel system layout, just a layout which shows the entire routing in a rig. So there will be pumps, there will be storage tanks, then supply to mud pits, cement tank, all will be shown in this one. You will see the details like, okay, in the detailed view, this is the emergency generator fuel piping detailed view, where inside the generator room, the tanks and supply return hoses, service outlet sizes, all these details will be seen here. This is a fill connection. Earlier we discussed about the bunkering station on port and starboard side. So similar kind of arrangement will be on the port and starboard side. There will be isolation valves. There will be flow meters in certain rigs. There will be flow meters at this location, and any connection to hoses will be usually hammer unit. So this is a detail. Okay, right now what we are seeing is a bunkering hose. Similarly, the next picture is fuel oil purifier. It's an alpha level make. It's a fuel oil purifier. It's a fuel transfer pump. So fuel transfer pump, earlier we discussed, there will be two fuel transfer pumps. So fuel transfer pumps will be gear type pumps because of the viscosity of fluid. So mostly all the transfer pumps will be gear type, and it will have a relief valve on the discharge side to control the pressure in the system. Also, if required, for mud pit operation inside mud pit, we may need huge quantity of fuel to be pumped suddenly in a short time. So in such case, we can use a separate pump, which will be a centrifugal pump, because if the flow rate required is higher, we go for a centrifugal pump. So the transfer pumps generally capacity in rigs is 50 gallons per minute. That is a transfer pump rate provided. The main generator set, like 3 to 4 main generators will be provided in offshore oil rigs for power generation. Like for normal operation, generally one generator will be running, but for drilling operation, we need more power because of the drilling equipment operation. So 3 generators, up to 3 generators at 70 to 75% load will be used in the rigs. Okay, what we are seeing is air-cooled fuel coolers. So this fuel coolers, which we described earlier, is used on the return line of the generator fuel system. So generator fuel system return line passes through the fuel cooler where fuel is cooled and put back to the day tank. So this is a picture of an emergency generator. This will be kept in a separate emergency generator room. So we described earlier. Usually the requirement varies like 900 kilowatt to 1100 kilowatt, depending on the emergency generator load calculation. There will be a load analysis which will be done for the emergency generator. Okay, what we are seeing is the purifier data sheet. Usually when we design a system, we receive data sheet for all the equipment. It will have the connection details, sizes, what is the equipment weight which will be used for lifting. So all these data will be available during design. Okay, now we will see about the Lube oil system. Like Lube oil system also has Lube oil system has two tanks. One is for main engines and one is for mud pump room. The main engine tank supplies lube oil for the main generator engines because the engines require lube oil for lubrication and cooling purpose inside the engine. Lube oil is used. So this is the two tanks. So from bunkering station, either port or starboard, we can fill on the main engine tank or on the mud pump room tank. So this is the bunkering process in the lube oil system. Now we'll see main engine supply, like the generators, each generators has engines. So lube oil tanks for main engine will supply to the generator engines. And in the supply line, as stated earlier, there will be quick closing valves which can be activated outside the machinery space. There will be there will be the transfer pump which transfers lube oil to the generators. Also, there will be a flow meter which can measure the flow, the flow quantity which happened during the transfer process. We will see the lube oil system. This is the overall layout of lube oil system. This has it shows the two tanks supplied to generators and feeding to the equipments. The pump and the flow meter is shown. In detailed view, like for main engines, this is the above main deck is the bunkering station and feeding to lube oil tank. In this particular detail, just a capacity is shown like 600 gallons. It can vary depending on the rig design. So this is for the mud pump room. There will be a flexible hose which we can use to supply to whichever equipment required. So that is a arrangement inside the mud pump room. Okay, with that we finished the presentation. It was made short to make it concise, so we can answer the questions or doubts. Okay, you can post the questions or any doubts in the Q&A. If required permission to talk, you can raise hand. We have the option to activate that one. Okay, first question. Fuel supply to main engines from hull storage tanks to purifier first or transfer forms first en route to dead tanks. Usually it depends on the operation. For normal operation, from hull storage tanks, we supply to purifier. So this purified oil is supplied to the dead tanks for operation, and batch purification is done like after bunkering. We provide the we purify the fuel inside the storage tanks itself. So in that case, depending on the condition of the fuel, if that is a case where we have purified oil in the storage tanks, we can supply directly from the storage tanks to day tank. The basic concept is to provide purified oil to the engine. So if we have storage of purified oil in a separate storage tank, we can pump from that storage tanks to the dead tanks, and from the dead tank we can use it for generator supply. I hope that is clear. Any more questions? More questions can be posted. Okay. For fuel oil system, what type of valves are used? More butterfly valves or ball valves, and which materials? Yes, for fuel oil system, like mostly we use gate valves. Gate valves are preferred. Gate valves, also ball valves are preferred. Butterfly valves can be used, but generally it needs to be fire rated considering the safety of the system. So that is a thing. And the materials which we use is like castile body with SS internal material. So that will provide the required ductile property for the valve. Okay, and for fuel system pipes, yeah, there is a question asking for the pipe material. It will be carbon steel pipes like SGMA 106 grade B. Pipes can be used. So usually schedule used is like schedule 80 or schedule 80 or schedule 40. So that is a thickness which we can use for fuel system. Oh, okay. Typical P&AD. There is a question asking for typical P&AD of dead tank arrangement. Can you please show again? Dead tank arrangement. Okay, just a minute. This is the total P&AD, like for the system. If you are asking for this, I don't know. I'm not sure whether you're asking for total P&AD or a separate one. So this is a total P&AD of the system. Here we can see the entire arrangement. Okay, so next question, do we use additional strainers for fuel oil lines to engines? Yes, we can provide strainers. We can provide additional strainers. Like on the pump discharge side, transfer pump discharge side, we can provide strainers. Similarly, all the engines supplied coming with the generators will have separate strainers, like duplex filter strainers. Will be two strainers, so which purifies the oil, which separates water from the fuel oil. So strainers are provided in addition to the equipment by the system. That depends on the client requirement. If the client wants to means in the design criteria, if it is asking for strainers, we provide additional strainers. Okay, there is a question asking for what are the instruments used in fuel oil and lube oil systems. All are pneumatic. Yes, pneumatic is preferred, considering the safety of the system. The instruments used, like we use the flow meters, similarly gauges, measuring devices, then temperature indicators. So all these are the instruments used in the fuel oil system, fuel and lube oil system. And if any equipment which needs to be powered is used, you're right. We prefer pneumatic equipments, air supplied equipments, considering the safety of the system. Okay, so that was a questions raised. If any more questions, you can post in the Q&A session. Q&A part. Okay, there is a question asking for the pump detail of transfer pumps. As stated earlier, transfer pumps are gear type pumps. Transfer pumps are of gear type pumps due to the viscosity of the fluid. Like for fuel systems or lubricating oil systems, generally gear pumps are preferred. So these pumps will have a relief valve system to maintain the system design pressure. The capacity of pumps. Okay, capacity of pumps generally varies. Like usually we provide 50 gallons per minute. It can go it can go higher also. So for high flow rates, as stated earlier, we will have to use centrifugal pumps. Okay, there is a question asking quick closing valve, a manual or a pneumatic. Yeah, quick closing valve, it can be a pneumatic or hydraulic operation. A pneumatic, that is a new system, two systems provided. So it has to be operated manually, like the closing lever mechanism for the quick closing valve will be kept outside the spaces, outside the machinery space, like main generator room outside, or it will be generally placed on the main deck outside the entrance to the machinery generator rooms. And for emergency generator room, it will be outside the generator room. So we have to manually activate it, but the system inside will be either hydraulic coil operated or it will be pneumatic. Or usually another option is a combined supply will be there, like pneumatically operated hydraulic levers. So this will ensure the closing valve operation. Yes, so I think that is clear. Okay, oil coolers. Okay, detail about oil coolers. There is a question. Yes, oil coolers usually it is air cooled. Like there will be fan in the cooler. So this will cool the return fuel oil. So this cooled fuel oil is passed to the air tanks. Okay, what is the next question? What is the normal pressure and temperature range for the fuel system? Okay, usually the design pressure for the system will be 150 psi. That is a 10 bar. So that will be the design pressure of the system. And the temperature system, the system will be designed for like 60 to 70 degree Celsius operation. But the fuel of oil will be less than that temperature. It will not be allowed to heat above 60 degrees. So that is the normal pressure and temperature range for fuel system. Yeah, yes, okay, that is clear. I think what is now, yeah, that is clear. Okay, the questions so far posted are answers. Yeah, any more questions you can post in the Q&A part. Okay, we have more questions. What will be transfer pump capacity? Yeah, transfer pump capacity will be like 50 gallons per minute. It can go higher depending on the rig design, but generally because of the usage of gear pumps are used with lower capacity flow rates. So since the transferring is a long hour operation, it would be continuously in operation. So we use pumps with 50 to 80 or 100 gallons per minute capacity, and the pressure will be like 4 to 8 bars, like 6 to 8 bars. That will be the normal range. So that will be the transfer pump capacity. If transferring to mud pumps, no mud pits, like this, that may require higher flow rates. So in such condition, we can use centrifugal pumps. A separate centrifugal pump apart from transfer pump can be used for transferring storage fuel oil to mud pits. So in that case, we can go for higher capacity pumps because of the centrifugal pump advantage. Yes, there is a question. Leak from fuel oil lines back to fuel tanks or dirty oil tanks. Leak like any containment, like any fuel oil spilled or any containment fuel oil will flow to dirty oil tanks. We will not be taking it back to fuel tanks. It will go to dirty oil tank because any dirty fuel which goes to fuel tanks can contaminate the storage or dead tank, whichever tanks it is pumped. So the design of the system ensures that any spilled or any dirty fuel which is accumulating in the combing area of various equipments like fuel oil purifier, etc., or fuel oil transfer pumps. This will flow to dirty oil tanks. Okay. Yeah. Is lube oil flammable? Yes, lube oil is flammable. Okay, what is the purpose of day tank? Yeah, day tank. Day tank is the service tank. Day tank provides the fuel for the service of the equipment, and day tank is a class requirement. There should be separate day tanks provided for a day of operation. It is usually considered for a day of operation, but the class rules states that minimum 8 hours of operation has to be ensured. So when we design the tank capacity, like if the rig requires 3 generators for drilling operation, we calculate the consumption based on the 3 generators in operation for 8 hours. Usually it comes to around 10 to 11 meter cube for normal jackup rigs. But in that case, we considering the safety and additional fuel required, we add like we provide around 14 meter cube capacity for the day tanks. The purpose of day tank is to provide fuel for the equipment operation. That will be the service tank. The storage tanks, which we described earlier, it is also called settling tanks, where the fuel settles like water fuel is stored there, and there will be a settling action, which is mainly settling and storage. Like there will be segregation in the ships, but in offshore oil rigs, the storage tanks are hull bottom tanks. So settling action is not coming into much effective here. And this day tank provides the fuel for equipment. Yes, so that is so far the questions are answered. Yes, there is a question about high suction, low suction. Yes, high suction is taken from the storage tanks. Okay, high suction, low suction. Yeah, yes, actually we take. Okay, just a minute. High suction, low suction. What is the purpose? Yes, in storage tanks, two level of suctions are provided. One is a high suction and one is a low suction. So we use both suctions depending on the condition of condition of the fuel in the tanks. So high suction is used for a certain operation, and like there will be accumulation of possibility of accumulation of water on the bottom part of fuel tank, because fuel oil, although we get a good quality of bunker fuel, there will be water content present in the fuel oil. So this water accumulates on the bottom part of the tank. So for normal operation, we take a high suction, like the from the higher part of the tank. But if the tank level is coming below that, then we go for a lower suction. Okay. So next question, is there any filter used between tanks and generators for removing impurities? If yes, what type? Yes, there are filters used, which we mentioned like strainers. So it will be a duplex type. Duplex means it will be very fine filter type. So these filters remove the impurities, any dirt particle or any solid particle impurities present in the fuel will be removed. So in addition, between the tanks and generators, there will be strainers. In addition to it, generators, there is equipment supplier. Generators, main engines has separate filters. In addition to system filters will be provided by us during system design. In addition to it, equipment has separate filters that also will be duplex type filters. Yes, so we have answered most of the questions raised here. So any more questions you can post in the Q&A. If no more questions, I hope the presentation is clear. The recording of this presentation will be shared if any person who missed to attend, or who registered and like logged in and logged out due to network issue, will get a recording of this presentation. Any more queries you can send to the mail IDs in the registration page. Okay, so with that, we are clear. We will wind up the session. Okay, thank you for attending the webinar.